Hey everybody, this is Mike with Plus 8 Precision, and I'm going to do another video on the KONDIA POWERMILL. This is not a how-to video, it's kind of just going to explain to you what I had to do to work around some things. So, let's get started. Alright, what you're looking at here is the motor, the original motor I assume, off of the mill. And this mill is, I believe, from 1969. And several weeks ago, I was doing some work. I've been doing quite a bit of job shop work out here. And I started smelling something funny, but I wasn't sure what it was. It didn't really smell electrical. And I had a problem with my switch. And I had redone my switch, so I didn't know if maybe the switch was some of the cleaning spray that I used in it was burning off, but, there was a smell. Well, as I'm working, the lights in the garage flickered, the fluorescent lights above. And it was raining and storming outside at the time, so I thought, well, maybe it was starting to lightning or something. So I looked up to see if it did it again, and I'm waiting for a crack of thunder or whatever. And about that same time, I seen a little bit of smoke wisping up from the motor. So I hurry up and shut everything off because the spindle started slowing down all on its own without even being under load. And lo and behold, I reached up and touched the motor, and this casing was hot as fire. I mean, you could literally fry an egg on the thing. So I shut everything down and stopped working for the night. Came out the next day after I got home from work, after everything had cooled off, turned everything back on, and the motor turned on. And for all intent and purposes, it sounded like it was running normal. But there was smoke, and I know I saw smoke. So I started checking things. I started checking the electrical, which the electrical legs on the motor, the power box to the mill, they weren't balanced any longer. And I know when I built my rotary phase converter, they were pretty close to being balanced. I mean, they weren't spot on number for number, but they were really close, within a percentage. And this time, say I had 240, 238, and I had 219. So I didn't know what that meant. So, I'm not an industrial electrician or anything, but I do my own work on certain items that I feel comfortable doing work on. So I'm like, well, is it the motor? Is my rotary phase converter going bad? I don't know. So here we are at the rotary phase converter. 3 horsepower, 3-phase motor. Rotary phase converter. I've done a video on this. The only thing I could think of that might have gone bad was a capacitor had popped or so. So I went through and did the best I could, since I don't have a capacitance tester, but I tested the capacitors to see if they would accept a charge, a very light charge, and they did. They accepted the charge, and they could withdraw the charge using my digital multimeter. I checked everything else. I checked all the wiring to make sure all the connections were tight. Everything seemed good. So, I'm nervous about running any of my other mills, or not mills, any of my other machines at this time, my lathe and my surface grinder, because I don't know if the rotary phase converter is bad, and I don't want that burning up my other motors. So, what do I do, right? What do I do? So, back over to the motor. So I decided to remove this from the mill, and I disassembled it all the way down. Took the armature out a whole 9 yards. Right about now, maybe you're seeing some still pictures flashing because that's all I have of that work, because during this time I did have some work that needed to be finished. So I was trying to do this as quickly as possible to see if I could see a cause or something. And you can see from the pictures, and I don't know what picture you're seeing right now, but you can see in the pictures there's some burned windings. So something got hot. Again, This motor is from 1969, so that puts it at, what, 52 years? I'm guessing it's original. There's a motor tag right there. This is a Spanish-made machine, and this looks like it's in Spanish. So, took it all apart. I needed to measure a bunch of stuff. I needed to see what was going on. Some of the motor shops, electrical shops around here said if I give them a bunch of dimensions and some pictures, they could probably quote a price, an estimate, to rebuild the motor. So that was my intent, was to try to look for myself to see what was going on, as well as put some dimensions down on paper, get some still pictures, and send that out to see what kind of quote would come back for rebuilding this thing. So that's what I did. You see the pictures. And I could take a look at how this thing was constructed. This is a 1.5 horsepower 3-phase motor. I don't remember what the shaft diameter is right now. But you look at this thing and it's quite specific. This here is the adjusting plate. I have a pulley, step pulley motor, or a mill. So you have a pulley here and a pulley that's on the main shaft. And then one of these is a pivot, and the other one is the lock. Looking at this, this would be the pivot, this would be the lock over here. Not important, but so what do I do, right? So I start hunting down motors. How much do motors cost? $400, $500, $600. You know, they're around. Some are on eBay. Some are here, some are there. Finally, the quotes start coming in. I know this is long, and it's all talking. But I did get a couple of quotes. One quote was for $4,000. I just laughed that off. I mean, I figured they just didn't need the work. They had plenty of work, and they were just blowing me off. Another company said it would be a minimum of $1,000. Even then, you know, it's an old mill. If I'm going to start spending $1,000, I might as well just buy a better used mill. So that was even a joke. So I'm looking and looking, and I finally contact one of my friends who's been in the business forever. He gives me a name and number. They've got a motor that's in California, but it's like $850. Another $100 and something for shipping. And guess what? The shaft is not the right shaft. So I'm going to have to do something anyhow. So it's not even ideal. And same thing on eBay. You could find lots of motors that are 1.5 horsepower, 3-phase, 1800 RPM, but the shaft is way smaller. So I'm just hunting around. What do I got to do? Put everything back together quickly and try to limp through finishing up my work. At that point in time, all I could do is limp through on this mill. I mean, I could run the machine for maybe consistent 35, 40 minutes before the motor was so hot you couldn't touch it. So I'm just barely doing the minimum amount of work that I can do. You know, I'm trying not to take long facing cuts. Just because of the way the machine is acting. And it's very frustrating. It's very disheartening. I'm trying to get all the work done. Eventually, I do run out of time. The customer wants their work back. I got to take a couple pieces back that I couldn't get to just because the mill, it was just, you know, I couldn't rely on the mill, and I didn't want it to go any further than it had already gone. So, you know, I'm almost out of options. I'm pricing out mills, trying to look at what some friends have. A couple of friends had some stuff for sale, but I got to move it. I got to get it over here. Some of them didn't have digital readout. Some of them had this, some had that, you know. I mean, if I'm going to get another mill, I want to replace the step pulley with a variable speed. I want digital readouts. I do have a digital readout I could take off of here. I want the gibs and the ways and everything to be good. You know, I don't want to have to live with problems like I do currently. You know, this mill I bought years ago, 5-6 years ago, and the mill, the digital readout, the vise, not this vise, my Wilton vise, rotary table were all $1,500 or so. So it was a good deal. I couldn't pass it up, and it got me started doing some machine work. So now I get on Facebook Marketplace and looking to see if by chance somebody's got a motor on there. And there's a lot of motors. Well, I ended up coming across a guy that was within a couple miles of my house. He had a 1.5 horsepower 3-phase electric motor. And I'll show you what I got. climb all the way up here. All right, here's the motor I got. Well, the guy had it on Facebook Marketplace, and he wanted $40 for it. He said we could test it when he got there. Well, when we got there, he had it plugged into the wall, just like a regular outlet. So obviously this thing is just humming. It's not doing anything. And I'm like, I thought you said we could test this. And he goes, well, we can. I got it plugged in, but it's not turning. And I said, well, that's just a regular wall. This is a three-phase motor. He didn't know even what three-phase was, didn't understand it. So he's like, just take the thing. So I told him, I said, well, if I get it home and I can test it out and it works, I'll pay you for it. I'm not trying to get anything for free, but I don't want to buy something that doesn't work. I already got that at home. I got a motor that don't work. So I get it, bring it here into the shop, and it sits on my cart for a little while because I had the work to finish. Finally, I get around to testing this, and it worked. So it works, great. Okay, I got a motor that works. It turns on, it spins, but this one is 1725, not 1800. So that's where like a 5% difference in speeds. Not a big deal, can live with that. Shaft is a little bit different size. I made a sleeve. I wish I could show you that, but I cannot because it's hidden behind the pulley. And the main thing I did was I got this plate made. I was going to make it myself on a rotary table, but at work, I have access to guys that run large 5-axis mills. So I quickly designed up a plate in NX and had one of the guys cut it out of some mild steel and came home with a plate that was finished. Mocked it all up, realized I needed to cut a little pocket, which I don't know if you can see that. Had to set the motor in about, I think it was 5 millimeters. So I had the right protrusion from the shaft, so the pulley, the motor pulley was in the right position, so the belt stayed aligned. And the way it's held in there is the screws that are on the motor casing, I drilled and tapped 1032s into this plate, and that's what holds it in here. And then I just drilled a couple of holes here, which I should have drilled and tapped just like the original because they won't adjust easily, so that's why I got this wrench on here. I'm going to go ahead and weld a jam nut on here, and then that way it'll be almost like it's threaded. That one I just used a nylock nut, and that stays in place. But everything works. And that's the key, right? So, you know, $4,000, $1,000 down to a plate from work and a free motor that I ended up paying $40 for to get this thing back up and running. And the difference in RPMs is almost invisible. So, you know, you can't just take the first thing that comes your way. Sometimes you got to think outside of the box and work around things. I mean, we've all got machine tools in our garages or shops or what have you, right? So let's use them. I mean, I could have limped through and made that plate. I did start cutting one out of some plate stock that I have here. And I torched it out and was just going to put it, like I said, on the rotary table and cut it all around and do everything else. It probably wouldn't have been as pretty as that plate up there, but it would have functioned the same. So, I mean, that's the only video I have for you this week. And again, the still pictures kind of tell the tale. You see what's going on inside that motor and, you know, dealing with people getting quotes back to you and just giving you the runaround on the quotes, prices that are just insane. You know, look for every option you can explore. There's definitely a solution out there. It just matters how persistent you are at finding it. And for me, you know, my wife will tell you that I'm a cheapskate, so even spending $400 on a motor, unless it would bolt right in, just and we'll go back and look at that motor real quick one more time. I just wanted to reiterate the fact that this plate that the motor mounts to and mounts to the mill is part of this motor. You know, there's inside here is a cast and machine bearing cup for the shaft and the armature. So it's not like I could just take this off. I would have to do a lot of work to use this. Plus, you know, I don't know whether that other motor would have worked on this. I didn't bother checking it because, you know, this is not solid through here. This is all hollow in here. So I don't know where those screws fell on there. I did make a template, but I can't locate it right now, so I don't know how the other screw position would match the screw positions for here. So it was just easier to make a new plate. Again, I had access to a machine to do it while my machine was pretty much down. So that's the route I took. But I hope this, you know, if somebody's having a similar situation with a bad motor or any kind of a thing on their machine, there are workarounds. You don't have to find the exact replacement. Pay the big cash that somebody wants, you know. And in this case, not being a Bridgeport, being a Spanish-made imported mill from 50 years ago, guess what? I don't think these parts are around. So hopefully you liked the video. If you got any comments, leave them below. If you got any statements, leave them below. Hopefully, you know, my videos make you want to subscribe to my channel. You know, I try to post as much as I can do, as I've always said, but work life and working in the shop life sometimes gets in the way of making videos. So give me a thumbs up. Hopefully you got something positive to say. Hopefully you like the videos. Check some of the other videos. I'll put some other videos in the links in the description on this mill, the power feed that I recently installed before this motor took a shit. Thanks for watching. This is Mike with Plus 8 Precision. See you on the next one.